Alright, so here we go. So first off, P and Q, they scare us. So let's put some real numbers in so that we can get a better feel for what's going on. So when you're choosing your own numbers, make them small, but not too small so you can see what's going on. So I'm thinking maybe she'll make 12 cookies and he'll make 18. I don't know, but we'll see. So she makes 12 cookies and he makes 18, and they want to package their cookies separately so that each bag has the same number of cookies. All right, fine. So if she's packaging her cookies, she's got 12 cookies. So she's got lots of possibilities for her cookies, right? She could have just one bag and put all 12 cookies in them, right? Or maybe she could have 2 bags and put 6 cookies in each. Or 3 bags with 4 cookies, or 4 bags with 3 cookies. She couldn't have 5 bags, because then she would have to break up her cookies and that would be sad. And she wouldn't be able to use them all. So, but she could have 6 bags with 2. And you can start to see that at this point here, it starts to repeat, right? As soon as you get a number that's up there, you're going to start climbing up the other side. So the next one is going to be 12 bags with 1 cookie in them. So these are all the ways that Marianne can package her cookies. Now for Jeffrey, Jeffrey can take his cookies and do the same thing, right? Jeffrey's got 18 cookies, so he could just have one big bag of 18 cookies. Or he could have 2 bags with 9 cookies. Or 3 bags with 6 cookies. Couldn't have 4, because 4 doesn't go into 18 evenly. Couldn't have 5, but he could have 6. And notice here, we start to repeat. So you can just climb back up the other side. The next one's going to be 9 with 2 and 18 with 1. So these are the ways that they can possibly package their cookies, and they want to do it so that each bag has the same number of cookies. So, like, how many cookies should they put in each bag? So Marianne's got a way that she can put 12 cookies in each bag, but poor Jeffrey does not. So they can't do 12 cookies in each bag. Marianne's got a way to put 6 cookies in each bag, and hey, so does Jeffrey. So 6 is a possibility. Marianne's got a way to do 4. Jeffrey can't do that. Marianne's got a way to do 3. Marianne's got a way to do 2. Marianne's got a way to do 1. So they could possibly package their cookies with 6 cookies in each bag, 3 cookies, 2 cookies, or 1, so that they all have the same and everything's taken care of. So now we kind of have an idea of what's going on. What were we doing here, right? What are these numbers? These numbers are factors, right? These numbers are factors of 8 or 12 and factors of 18. So they're factors of P and Q is what we were finding. And when we were circling them, we were circling the factors that they have in common. So we were finding the common factors of P and Q. And hey, look, that's there. So B is our answer. That's what they're looking for. Now, done with the problem, but just to kind of examine what's going on in the rest of these, let's do that. So if we look at the first one, common divisors. Now divisors are actually the same thing as factors. They are synonymous. So we're thinking, oh, yay, common divisors. We found some common divisors, but that's a P plus Q. And that's not what's going on here because they never had to add their cookies together. They're packaging their cookies separately. So if they combined all their cookies and tried to figure out how many they could put in a bag, that would be our guy. But since they're doing them separate, it is not. All right, so A is out because we never had to add the 12 and the 18 when we were figuring this out. So if you look at C, prime factors of P times Q. Now this one's just out there, right? We never had to multiply P times Q together. And primes, as good as they are, like why would we want to only put a prime number of cookies in our bag, right? No. Common multiples of P and Q. We found factors, not multiples. So just be careful that you get the difference between factors and multiples. So like factors of 15 are like 3 and 5. But multiples 15s, think multiple 15s, right? 1 15, 2 15s, 3 15s, 4 15s. They're numbers that are bigger than 15 because you have multiples of them. And so we never had to find multiples of 12, 12, 24, 36. That was not a part of this. Nor did we have to find multiples of 18, 18, 36, and so on. We found their factors, not their multiples. So that's out. So now we are quite satisfied that this was the correct one and all the rest are not so great. And that's that.